Kia ora class, this is Mr. Wang. I'm your science teacher for this year. And as you know, unfortunately, I just came back from China, so I can't be with you guys in the first 2 weeks because I have to stay at home. And that's why I'm making this video for you guys so that you guys don't fall behind and can catch up on the things that we need to do in school, okay? So yeah, so first I want to talk about, what is science? And normally I start with my lesson and explain what science is. And interestingly, at the moment, we are having this big outbreak of coronaviruses. So I think I'll use this as a content to explain what science is. So as you know, so in ancient time, we don't know too much about science and we don't know how this world works. So we slowly accumulate like different ideas, right? So, but nowadays we have a lot more information. Say this coronavirus, if it happened, say 500 years ago, like the Black Death that caused half of Europe's population like just disappeared. So half of Europe died because of the spread of a virus. So this virus is just as bad, except that nowadays we know so much about these viruses and how they behave. So even though we don't have a cure for it right now, but at least we know what it is and we know how it behaves. So the least thing we can do is just to try to contain it. So that is because of science, because we've learned about it. So I was reading a book last year. They say humans have three biggest enemies, and these three enemies kills lots of people. And when they happen, there's just not much human can do. So these three enemies or crises of human are, the first one is a war. So if there's a war and then lots of people die. And then the second one is a famine. If someone has a famine, like say the weather is bad, the crops did not grow, or there's a lot of bugs coming over, eat all the crops, and lots of people dies. And then the third one is an epidemic, which is a spread of a virus. So through science, we pretty much solved all of three problems now. We still have a little bit of it here and there, but we still pretty much solved it. So for example, war, like nowadays, like people travel so much because of the internet, because of the airplane, then people travel around the world, and war mainly happens because there's a lot of misunderstanding between human races. So this country thinks, well, that country is bad doing that, and that country thinks, oh, this is bad, and they try to take over each other's resources. But nowadays the world is so communicated, there's so much communication, and it's so connected with each other. So the chances for a war is getting less and less, even though that there are still wars going on in particularly like in the Middle East or some other like places, but on a big scale of things, like those are a lot smaller compared to like what previously happens in human history. So the second one is famine, right? So you guys probably haven't heard of like this because we haven't had a famine for a long time. The main reason for that is nowadays with biology, and we are able to breed things together to create a better plant. So, and for example, kiwi fruit as a typical example. So all the kiwi fruits sold in New Zealand or produced in New Zealand are a breed made by a company called Zespri. Okay, so if you go to the supermarket, you see kiwi fruit being sold, highly likely they will have a Zespri sign on it. The reason why it has a Zespri sign on it is because Zespri, this company, they actually breeded the kiwi fruit. And kiwi fruit used to be called the Chinese gooseberry. So they're actually from China. So they came to New Zealand before I came here. So, and people took them here and then they crossbreed the strawberry. They make the strawberry become bigger and bigger. And we learned this in biology and genetics. How do we do that this year? So once the kiwi fruit gets bigger, and then we want the sweeter one as well. So we crossbreed them to make them sweet, make them big, make them juicy, and make them like stronger so that the disease will not harm these fruits. So in that way, we be able to grow them really big. Another example of it is like a banana. So a banana, if you search online, what did banana look like, say 1,000 years ago? So it looks completely different from the banana you see today. Banana is not that big. Banana does not have that much of energy. So sometimes I just eat a banana for breakfast, and that's it. That's all I eat in the morning because I don't like eating much in the morning. So, but back in the old days, this would not happen. So in this way, because of biology and science, like we were able to produce using very small quantity of land and be able to produce a lot of food, so that so famine has probably pretty much been solved by us. And I mean, if a famine happens in a certain area, we can always transport food from other areas, because you're not going to have a famine like the whole world. Typically, it's only a certain area they might have it now and then. So yeah, so the third one is the epidemic. So hopefully we can find a cure for this this virus very soon. But even if we can't find a cure, at least we can contain it. So this has happened to say Ebola or SARS or MERS or a lot of the other viruses that we've had. So this new coronavirus, it will be contained, and we're doing everything we can. So part of it is I have to stay at home for 2 weeks before I can return to school. And so there's nothing to worry about. Just, I was really safe, and I was at home, and our city has no people being affected when I was there, and we don't go out, and every time we go to the supermarket we have to wear a mask, and people check your temperatures everywhere if you travel. So but I have to stay at home, so it's just a precaution, because it's a virus that can spread. So anyway, so we just follow the government's guideline, I guess, for all of us. So there's nothing to worry about. Okay, so let's come back to this lesson that we're gonna have. So yesterday you've watched the Bill Nye Science Guy video. I hope you enjoyed that. That probably give you quite a bit of information about atomic structure. So my video is not as interesting as his video, because he can do all these crazy things but I'm just gonna go over through my notes so that you guys feel confident of what's going on. And okay, so on the first page, so I've written down, so as you know, like we don't know what the world is made out of, okay? So, but one day someone find out, oh yeah, I think everything is made out of atom, okay? So what is atom? Atom in Greek, so back in the days, all science languages are written in Greek. So it doesn't matter if you're from France, you're from Germany, you're from England or Scotland or whatever, China, or not China, China don't do Greek. But anyway, if you're in Europe, like you use Greek as the language for scientists, so they can communicate with each other, because there are so many different languages over there. And so this person, Joe Dalton, so in Greek, atom actually just means unbreakable, because they think this is so small it cannot be breakable. So John Dalton said everything is made out of atom. Right? So if I have this piece of paper here, I put it apart, I put it apart, I put it apart, and eventually I can make it smaller to something that's so small it cannot be break anymore. So let's call this unbreakable. So this is called the atom, and that makes everything, okay? So, and obviously John Dalton see atom before? No, atoms are too small for anyone to see at that time. So nowadays we can see, we use an electron microscope, we can see it, but back then we don't know, okay? So you might heard of proton, neutron, electron, but back then nobody knows about them. So there's only atom. Atom are the smallest particle, makes everything, okay? And then we had a breakthrough. So through an experiment called the Cathode Ray Experiment, so you can learn that in the future, or if you're interested, you can Google it. So we found out, oh, actually atom is not the smallest thing. Inside the atom, there's something called the electron, and this electron actually have a negative charge, okay? All right, so and then J.J. Thomson. So J.J. Thomson is a scientist. He said, oh, perhaps atom is not the smallest thing because there's electrons coming out of it. So what I'll say is atom is just this pudding. It's like a pudding. It's a sphere, okay? It's a round ball. And then inside the round ball, there's some negative electrons evenly spread out. So these are the plums, okay? So plums. And so the ball itself is positively charged, and then the electron are negative. So now overall they still become neutral. Why are they neutral? Because if I touch my glass, if I touch my face, if I touch my table, I'm not going to get electrocuted. So that shows that everything is neutral. If it's neutral, that means, well, the negative and positive must balance each other. So if there's negative electron, there must be something positive. But what is positive? He doesn't know. So he say the ball is positive. Okay. So that is the second model we see over here. All right, so science involve, people do experiment, people came out with new theory, and then bang, we have a New Zealand scientist, Ernest Rutherford from Nelson, okay? So he came out with an experiment called the gold foil experiment. So if you have time today, so you can watch a YouTube video about gold foil experiment. So he's able to find out, so atom is not a big ball with plumes, electrons just evenly spread in the middle. Rather, atom is just empty space. We think atom is like this, but really it's just all empty space. Except in the middle over there is something really, really small, but very, very heavy and positively charged called the nucleus. Okay, the nucleus. And then we already know there is also electrons. So where are the electrons? The electron floats around on the outside, and that is very, very light. It's a negatively charged. So, and that is atom, what atom look like. Okay, so that is Rutherford's model. Okay, and then after another while, so we have the Boyle model. So Boyle is a student of Rutherford. So they actually worked on this together in Rutherford's lab. So sometimes it's called a Rutherford-Boyle model. So Boyle was able to find out that, okay, so now we know the nucleus is in the middle, the electron is on the outside, but what is inside the nucleus? Is nucleus the smallest thing? It's just one ball. And then he was find out, actually nucleus is made out of proton and neutrons. Okay, so the example I've drawn you is, let's say we have a helium atom. Okay, so we can have oxygen atom, carbon atom, different types of atoms. But for the helium atom, I've drawn you, helium atom have 2 proton and 2 neutron in the middle. Okay, I'm using P and N to represent a proton and neutron, and there are 2 electrons floating on the outside. So that was Boyle's model. Boyle says this is what an atom look like. And nowadays, this is a common model that we use to explain to students. And so we found out other things about atoms, say proton, neutron. Are they the smallest thing? No, proton and neutron are actually made out of quarks. Correct, but that's a bit too complicated, and we don't need to know that for now. So for now, we just need to know, okay, atom is made out of proton, neutron, electron. And where are proton and neutron? Proton and neutron are together in the middle of the atom, okay? Binding together in the middle. And then electron floats on the outside. And this is like empty space all over here, just like the moon goes around our Earth. So that's what it looks like, okay? All right, so let's come to the second page. So the second page, I've written down the 3 particles that makes of atom. Atom is made out of proton, neutron, electron. So what do they look like? How do they behave? So proton and neutron are very, very heavy. They're in the middle, and then they're called the nucleus, okay? So, and then each of them, we say we have 1 atomic mass unit, okay? Because they're heavy and they're actually about exactly the same mass, just slightly different. So we say each of them have 1 mass, okay? And the unit, we give a special unit, just like we say 1 kg. Like, what is kg? Or we say, well, this is 1 kg. We call it 1 kg. So now we give it a new unit. So the new unit is atomic mass unit, okay? So proton has 1 atomic mass unit, neutron has 1 atomic mass unit. And then electrons is very, very light, so it has 1 2,000th of atomic mass unit. And proton has 1 positive charge, and electron has 1 negative charge. And then neutron has no charge. So that is something you guys will need to remember. So this is like the fundamental concepts of biology, of chemistry. Once we learn this, and then when we learn chemistry, and we're going to be using these things, and lots of physics as well, like especially electricity. Okay, all right. So out of these 3, if you ask me, say, which one is most important, and I tell you it is the proton number that's the most important. So the proton number, we also call it the atomic number, okay? So proton number determines what element it is. So for example, say today you were on the street in the lab doing experiment, and then bang, you find an atom. You get very excited. You say, whoa, I find a new atom. So my question is, well, you have to ask yourself, is this atom have already been found by someone? Or if this atom has never been found before, you're the first person to find this atom, okay? You're going to become a very famous scientist. So, well, what you need to do is you will need to break it apart and have a count how many proton it have. So if you see, there is 1 proton inside here, then what you found is actually just a hydrogen, because hydrogen has 1 proton. Okay, if you find, oh, there are 2 proton, well, then that's a helium. 3 proton, lithium, and 6 proton is a carbon. 8 proton, and that's an oxygen. Okay, so the number of proton tells you what element something is. So you've learned about element last year. So it's just made out of one type of atom, right? Okay, so proton number is also called atomic number, and that's the most important one. And so we put them together, we have the periodic table of elements. So, and then, but what about neutrons? Well, neutrons is not as important as proton, but it is also inside there, does not have any charge, okay? So, but they're important as well. And the next thing I want to talk about is, if we talk about atom is always neutral. If we touch it, it has no electricity, they're always neutral. So if there is positive proton, there are negative electron. So each of them have 1 charge. So they must equal to each other. Say if you have 5 proton, you must, so that's 5 positive charge. You must have 5 electron negative charge to cancel this. So it becomes neutral again. So if you see something, they tell you the proton number is 20. So if it's an atom, and then you know that the electron must be 20 of them as well. So in this way, you will be able to determine the proton number. So once you know the atomic number, you know the proton number and electron number straight away, okay? And then what about the neutron number then? So neutron and proton both have mass.